Users like to keep all their data stored in a single place instead of being scattered in different applications. However, they do want their applications to talk to each other and access the same data. Also, users do not like filling out forms to sign up for new applications. So to provide faster onboarding and convenient integration, developers use Oauth for access authorization across applications. It is an open industry standard protocol that lets applications access resources on behalf of the user. Version 2.0 is the latest version. The protocol manages this access securely without revealing any passwords to the client application. It allows users to restrict the level of access to applications and revoke it later if they would like. The participants include the user or resource owner who owns the data, the client application through which the user wants to access the data, the authorization server which authorizes the client application, and the resource server which has the user data. Usually the two servers are part of the same trust domain. These participants interact with each other through flows, hence the three-legged workflow this video is about. Consider a scenario. Dave wants to get some of his photographs in Google Drive framed. He finds an online service called Framers that would print, frame, and deliver the photographs right at his doorstep. Dave opens the Framers web app to order the prints. The app supports importing images from many photo sharing sites, including Google Drive. This means that Framers has registered with Google as an Oauth client already. It has a client key that Google identifies it with. Dave clicks the Google Drive icon. This triggers the process of acquiring temporary credentials, also known as a request token. These credentials will be used by the server to identify the authorization request that will be made to the user. A post HTTP request is made to the authorization server, which specifies the grant type we require as a response, that is, an authorization code, scope, which is read-only access in this case, a redirection URI to which the browser should return to upon authorization, and the client key. Server verifies the client key and responds back with a request token. Now that the client application has the request token as an identifier for the authorization request, it redirects Dave to Google's authorization page along with it. If he isn't already logged in, he'll be presented with the sign-in screen. Dave looks at the URL and makes sure he is giving his password out to Google only. Upon signing in, he is presented with the authorization screen where he allows Framers a read-only access to his Google Drive. Server marks the request code as authorized by the user, grants an authorization code, and redirects the browser back to the client application. Having the authorization code, the client application can exchange it now for an access token to the protected resources in the resource server. Here's a sample snippet of the post HTTP request with the authorization code sent to the authorization server. The authorization server responds with an access token. Now the application is authorized for around an hour by when the token will expire. This is enough time for Framers to fetch Dave's photos via an API call. In other cases, like a client application to post on your social media account, you'll need to get refresh tokens. Refresh tokens will get the access until it is explicitly revoked. I hope this explains how three-legged OAuth workflow works. Besides user experience and faster onboarding, it is more secure and also spares developers of having to spend most of their time on authorization. Let me know if you have any questions. Thanks for watching.